Hello guys, how are you today? So today I will be explaining the chemistry quiz. But before I start explaining the quiz itself, I'm gonna open these notes and I am gonna write a small summary. So in this chapter, or in this part of what we're learning, we're gonna take something called halogens. We've taken it before in grade 9 towards the end of it, but it's really very simple. What we need to know are four elements. They are fluorine, which we will denote by F, chlorine, which we will denote by Cl, bromine, which we will denote by Br, and iodine, which we will denote by I. It is in this order, Fickle-Brie, if you want to remember it, and you should know that F is the strongest. It's stronger than Cl, and Cl is stronger than Br, and Br is stronger than I. Now, what is the importance of this order? This order teaches us the displacement, meaning that F can displace Cl, can displace Br, can displace I. But Cl can only displace Br and I. It cannot displace F. And then Br can only displace I. It cannot displace Cl or F. And I cannot displace anything because it is the weakest halogen. So this is the importance of this order. Now, some things you need to know is that at room temperature, RTP, fluorine and chlorine are gases. Bromine is a liquid and iodine is a solid. Okay, so now let's go to a new page and let us discuss the properties of these gases. Okay, so usually when we're talking about fluorine, it is what? It is a yellow-green gas. Okay, and it is what? What is about fluorine? Is that it is the most reactive halogen. In other terms, this means it does not form a precipitate with anything else. So we will just write doesn't form precipitate with anything, or it doesn't even react too much with anything. Like, it's really reactive that it's just not considered as a reaction, you know? Now let's go to the next page and let us discuss chlorine. Chlorine is very important, okay? To test for chlorine, you just need to make sure that it bleaches litmus paper. It also has a choking smell. And it is a weakly acid. I don't know, it's somewhere in the quiz, but it says that it is a type of weakly acid, except for HCl, which is a really strong acid, but chlorine itself is a type of really weak acid. Okay, now after chlorine, we are gonna open a new page, and we are gonna discuss about bromine. Okay, bromine is a reddish brown liquid, and if it is in gas form, it is a brownish gas. Now, one thing I forgot to mention before is that all halogens are double bonded. So are double bonded. What does double bonded mean? Double bonded means that F, you can find it as F2. Cl, you will find it as Cl2. Br, you will find it as Br2. I, you will find it as I2. Double bonded meaning it's always 2. Okay? Now, the last thing we will talk about in the halogens is the iodine. Iodine, we said it can be found as a solid, and it is found as a gray-black solid, something similar to this color. Okay, and if it is a gas, it is a purple gas. Okay, now that we finished talking about each individual one, we are going to talk about their properties, the properties that make them halogens. Okay, like, why did we group them into halogens? Why are these called halogens and they're not, like, you know? To group something, they have to have similar properties. So let us discuss the properties of halogens. First of all, they are poor conductors for both heat and electricity. They're not insulators because they do not let them pass. They do pass, but they are poor conductors because they do not have free electrons. Next thing, they are very low solubility, meaning most of them form Most of them form precipitates, except for F. F will not form a precipitate because it's a really strong reactant. And they are all toxic. Every single one of them is toxic. Okay, now the final thing we will discuss about halogens is their tests with Ag. Ag plus, you add it to Cl minus, it is gonna give you a white precipitate that darkens upon exposure to light. You add it to F minus, no change happens. You add it to Br minus, a creamy precipitate forms, which darkens upon exposure to light. You add it to I minus, okay? A yellow precipitate will form that darkens upon exposure to light, okay? Now we're gonna move on to chapter 4, a quick and small summary of chapter 4. So, chapter 4, summary. Okay, first thing we're gonna talk about are, it is the definitions of oxidation. We have two definitions of oxidation. Two definitions for oxidation. Number one is the addition of oxygen. Okay? And then the second definition of oxidation is the loss of electrons. Okay? However, if we are talking about reduction, there are also two definitions for reduction. You have definition 1, which is the loss of oxygen or removal of oxygen. And then you have definition number 2, which is the gain of electrons. Okay? Now, another term for the reactants that go into oxidation, they are called what? They are called the reducing agent because they cause the reduction. So reducing agent or reductant. So reductant. So what I'm trying to say is that when an equation, like when a reaction occurs, you have oxidation plus reduction. Okay? The reactants that undergo oxidation, they are what stimulates the reduction, and the reactants that undergo reduction is what stimulates the oxidation. So that means the in the oxidation, the ones that undergo oxidation, they are the reducing agents, and the ones that undergo reduction, they are the oxidizing agents or the oxidants. Okay? Now that we are talking about oxidation, we are going to introduce something new. It is the oxidation number. I'm just going to write a quick definition. Oxidation number. I'm going to say the definition, then I am going to write it. Oxidation number is a fictitious, which means imaginary charge that is assigned to the atom, okay, when pairs of electrons shared between it and other atoms are counted according to certain rules. In other terms, in like a way simpler definition, oxidation number is the imaginary number that is the charge that is given to the atom in a compound, okay? Notice why I said compound, okay? Before we dive deep into why I said compound and I didn't say element, let me just write a quick definition. Oxidation number is an imaginary number given as a charge assigned to an atom in its compound. So this is like a very simple definition. Okay, I will repeat the original definition, which is like oxidation number is a fictitious charge that is assigned to the atom when pairs of electrons shared between it and other atoms are counted according to certain rules. In a very simple definition, oxidation number is an imaginary number given as a charge assigned to an atom in its compound. Now, why did I say in its compound? Because in its compound, the atom can share its charges with other elements. Because if you're considering an element itself, it's not sharing charges, which will counteract what is the definition of oxidation number. Because oxidation number, I'm gonna write it in red, happens only if charges are shared. So, if we go up, and we're gonna relate this now, oxidation number. First of all, what is oxidation? The very first meaning given to oxidation is the addition of oxygen, but then later on it got developed into the loss of electrons. How does something lose an electron? It has to give electrons, it has to give a charge because electrons are negatively charged. So oxidation number cannot work if it's not, like, if charges are not shared. Okay, and reduction is the gain of electrons. How can it gain a negative charge if it is not with another element? So that's why when we say oxidation number, it is in a compound. Now we are going to write a table. This table will help us understand better. So we will call this table of oxidation number. We're going to start, first of all, we're going to separate it, I feel, a little bit like this, okay? In the top, we are going to put the atom, and here we are going to put its oxidation number. So the first thing we start with is what we were talking about, is an elementary atom. What does an elementary atom mean? It means an atom itself. And we said an atom cannot give charges to itself. So that means its oxidation number is always 0 if it is an atom of an element by itself. Now, if they gave you a charged element or a charged atom that we call an ion, or a simple ion, not a complex ion, okay, for example, an A plus, S2 minus, etc., it's gonna take the charge. The oxidation number is the charge. Okay, so here it's gonna be +1, the oxidation is gonna be +1, and for this one it's gonna be -2. Now we reached fluorine. What about fluorine or fluorine, however you state it? Fluorine, because it is very reactive, okay, we put a definite oxidation number. It will happen all the time. Anytime you see fluorine, remember, -1 is its oxidation number. Moving on, I'm just gonna continue the table. Okay. After fluorine, we discussed, or we're gonna discuss group 1 metals. Not in their elemental form. So you cannot take them, for example, group 1 metals, lithium. You cannot take lithium as an element. No, you have to take Li plus for this to work. So Li plus, this is a simple ion, so it will take its oxidation number equal to its charge. However, if we are talking in a complex ion, so for example, Li2CO3, the charge of the Li in this compound, or this ionic compound, is gonna be +1. Now we're gonna move on to the next group, which is group 2 metals. Again, not in elemental form. Elemental form means not in their, for example, one of the group 2 metals is magnesium, Mg. Do not take Mg as it is, but instead you can take it as an ion, as in a complex ion, whatever, okay, as long as it's not in its elemental form. Its oxidation number is gonna be +2. Now aluminium is gonna be +3. Okay, so the oxidation number of aluminium is +3. Oxygen is an interesting case. If we're talking about oxygen with anything, then the charge of oxygen is -2. But if we are talking about peroxides, then the charge of oxygen is -1. One more thing I would like to add about oxygen. If you're taking, for example, OF, to find the oxidation number of this, you are not gonna like say, okay, this is -2 and the F is -1. No, what you're gonna do is you're gonna keep the charge of, or the oxidation number of, O unknown. So we're gonna call it X, okay? And then F, we know its oxidation number, which is -1. And now what is the charge? There's no charge over here, so it's equal to 0. So it is X minus 1 is equal to 0, so that means x is equal to 1. So in this case, the the oxidation number of oxygen is 1. I think this is one of the only cases in where the oxidation number of oxygen is 1. Otherwise, it's always minus 2. Now, moving on to a new page, okay? We are going to talk about chlorine and bromine. Okay, also chlorine and bromine is an interesting case. I'm just gonna write Cl and Br. Always their charge is gonna be -1 unless if it is with oxygen or fluorine. I apologize for my bad spelling, okay, or fluorine. Why? Because again, if we have, for example, BrO, okay, because it is on top, because it is stronger than Br, it's not stronger, but in a sense of this grouping, because they put oxygen above chlorine and bromine, we are gonna give O the definite charge. So O will take a definite charge of -2, and then we calculate the charge of Br. So it's gonna be x minus 2 is equal to 0, so x is then equal to 2. Okay? However, if it is, for example, Br minus itself, the charge of this is gonna be -1. Not the charge, sorry, the oxidation number. Now we move on to hydrogen. Again, hydrogen is also an interesting case. So hydrogen, if it's gonna be with a non-metal, for example, HCl, then hydrogen is gonna acquire a charge of +1. But if it's gonna be with a metal, for example, NaH, its charge is gonna be, not its charge, sorry, its oxidation number is gonna be -1. So HCl, this is gonna be +1. NaH, this is gonna be -1. Okay, and one thing I would like to finish off with is that acids and bases are not redox reactions. But what is a redox reaction? A redox reaction is very simply a reaction in which oxidation and reduction both happen at the same time. Okay, so let us give an example of a redox reaction. Just a very simple example I'm gonna give is 2Fe3+. It is aqueous. In addition to Cu+, it is also aqueous, is gonna give us 2Fe2+, which is also aqueous, in addition to Cu2+, which is also aqueous. Now, let us discuss this redox equation. If you notice, Fe3+, okay, forget the number of moles, okay, always, you never take into consideration the number of moles. Fe3+, its charge is 3+ in the reactant side. However, in the product side, its charge became 2+. So what happens? It gains an electron. And we said when it gains an electron, this is reduction. Now again, notice over here, Cu+, its charge was 1+ in the reactants, and in the product it became 2+. So that means it's losing 1 electron. And we said the loss of electrons is oxidation. Okay? Now, we said which one undergoes the reduction. The one that undergoes the reduction, we call this the oxidizing agent or the oxidant. And which one undergoes oxidation? The Cu+. So we call this the reducing or the reductant, the reducing agent. Okay? So this, we call this a net ionic equation. But there's one more thing. If you notice, sometimes they give us the paper in the chemistry exams, the table, the periodic table, and you flip it on the back, you have half reactions. What are half reactions? Since when did we ever hear this? Very simply, a half reaction should consist of three things. It should consist of an element, its ion, okay, and the electrons. So, for example, Na. Na, it loses one electron. So, it becomes Na plus, this is the ion. And the electron, what does it lose? It loses one electron, so 1e minus. If we're going to talk about Cl, Cl gains an electron, so we're going to put it on the reactant side. So Cl plus 1e minus is going to give us Cl minus. So I'm pretty sure this is all that is going to come in the AMS. Thank you guys for watching this part. Now I'm going to make a separate video for this quiz, and thank you guys for watching this one. Please watch the next.